Solve x squared plus 2x equals 8 by graphing. First write the equation in standard form. Begin by writing the original equation, x squared plus 2x equals 8. Then subtract 8 from each side of the equation to get x squared plus 2x minus 8 equals 0. Next, graph the related function y equals x squared plus 2x minus 8. From the graph, you can see that the x-intercepts are -4 and 2. So the solutions are x equals -4 and x equals 2. Solve x squared plus 4x equals -4 by graphing. First write the equation in standard form. Begin by writing the original equation. X squared plus 4x equals -4. Add 4 to each side of the equation to get x squared plus 4x plus 4 equals 0. Next, graph the related function y equals x squared plus 4x plus 4. Notice that the only x-intercept is at the vertex, -2, 0. So the solution is x equals -2. Solve x squared plus 4x equals -4 by graphing. Solve -x squared equals 4x plus 8 by graphing. First write the equation in standard form. Begin by writing the original equation. -x squared equals 4x plus 8. Then add x squared to each side of the equation to get 0 equals x squared plus 4x plus 8. Next, graph the related function y equals x squared plus 4x plus 8. From the graph, you can see that there are no x-intercepts. So -x squared equals 4x plus 8 has no real solutions. The graph of f of x equals the quantity x minus 1 times the quantity x squared minus x minus 6 is shown. Find the zeros of f. From the graph, you can see that the x-intercepts are -2, 1, and 3. So the zeros of f are -2, 1, and 3. The graph of f of x equals x squared minus x minus 5 is shown. Approximate the zeros of f to the nearest tenth. Notice from the graph that there are two x-intercepts, one between -2 and -1, and one between 2 and 3. Make tables using x values between -2 and -1, and between 2 and 3. Use an increment of 1/10. Then look for a change in the signs of the function values. When x is -1 and 9/10, f of x is 50/100ths. When x is -1 and 8/10, f of x is 400ths. When x is -1 and 7/10, f of x is -40/100ths. When x is -1 and 6/10, f of x is -80/400ths. When x is -1 and 5/10, f of x is -1 and 25/100ths. When x is -1 and 4/10, f of x is -1 and 64/100ths. When x is -1 and 3/10, f of x is -2 and 1/100th. When x is -1 and 2/10, f of x is -2 and 36/100ths. And when x is -1 and 1/10, f of x is -2 and 69/100ths. Notice that the sign of the function values changes between -1 and 8/10 and -1 and 7/10. When x is 2 and 1/10, f of x is -2 and 69/100ths. When x is 2 and 2/10, f of x is -2 and 36/100ths. When x is 2 and 3/10, f of x is -2 and 1/100th. When x is 2 and 4/10, f of x is -1 and 64/100ths. When x is 2 and 5/10, f of x is -1 and 25/100ths. When x is 2 and 6/10, f of x is -84/100ths. When x is 2 and 7/10, f of x is -41/100ths. When x is 2 and 8/10, f of x is 4/100ths, and when x is 2 and 9/10, f of x is 51/100ths. Notice that the sign of the function values changes between 2 and 7/10 and 2 and 8/10. The function values that are closest to 0 correspond to x values that best approximate the zeros of the function. In each table, the function value closest to 0 is 4/100ths. So the zeros of f are about -1 and 8/10 and 2 and 8/10. A A soccer player kicks a soccer ball 2 feet above the ground with an initial vertical velocity of 60 feet per second. The function h equals -16t squared plus 60t plus 2 represents the height h in feet of the soccer ball after t seconds. Part A. Find the height of the soccer ball each second after it is kicked. First, make a table of values starting with t equals 0 seconds using an increment of 1. Continue the table until a function value is negative. Substituting 0 for t in the function h gives h equals 2. Similarly, when t equals 1, h equals 46. When t equals 2, h equals 58. When t equals 3, h equals 38. And when t equals 4, h equals negative 14. So the height of the soccer ball is 46 feet after 1 second, 58 feet after 2 seconds, and 38 feet after 3 seconds. Part B. Use the results of Part A to estimate when the height of the soccer ball is 40 feet. From the table you can see that the soccer ball is at a height of 40 feet between 0 and 1 second and between 2 and 3 seconds. So the height of the soccer ball is 40 feet slightly less than 1 second and slightly less than 3 seconds after it is kicked. Part C. Using a graph, after how many seconds is the soccer ball 40 feet above the ground? To determine when the soccer ball is 40 feet above the ground, find the t values for which h equals 40. Substitute 40 for h and solve the equation negative 16t squared plus 60t plus 2 equals 40 by graphing. First subtract 40 from each side of the equation to get negative 16t squared plus 60t minus 38 equals 0. Then use a graphing calculator to graph the related function y equals negative 16t squared plus 60t minus 38. Then use the 0 feature to find the zeros of the function. So from the graph you can see that the soccer ball is 40 feet above the ground after about 8/10 second and about 2 9/10 seconds.